Hello and welcome. In this video, we'll continue solving past exam papers on limit and continuity. Don't forget to like and comment. The first question, which of the following is equal to the limit of the sequence, as you see here, quotient sequence. It says the limit of 3 radical n minus 6n plus 5 the whole over 4n plus 1 as n goes to infinity. When we are finding the limit of a sequence at infinity, we'll try to divide each of the term by the highest degree of the variable. Here the numerator and the denominator are same degree, which is degree 1. Square root of n means, n the power of 1 over 2, so that is less than 1, so the highest degree is just 1. So we'll divide each of them by n, then it's going to be the limit of 3 radical n over n minus 6 plus 5 over n. When you divide 6n by n will be 6, the whole over 4 plus 1 over n as n goes to infinity. This time 5 over n, as n goes to large number, it's going to be 0. The same thing, 1 over n also will be 0. But let us try to see 3 root n over n. How does it look? This one we can write it 3 radical n over radical n square. The n can be written in this way, and this is the same as 3 in 1 radical. We can write it n over n square. We can keep it. This is equal to 3 times square root of 1 over n. Again, as n goes to infinity, the one which is found in the radical will be 0. So this term also will be 0. Then what remains? In the numerator negative 6 and in the denominator 4. When you simplify, it will be negative 3 over 2, so the answer will be A. The second question, what is the value of the limit of x cubed minus 8 the whole over x square minus 4? Here, as x goes to some number which is 2, not at infinity. So what to do? First, we will substitute directly the number 2. If you substitute 2, the upper will be 2 cubed minus 8, and the lower will be 2 square minus 4, which is 8 minus 8 over 4 minus 4. That is 0 over 0. It is meaningless. So direct substitution this time is not advisable. It's not preferable. Better to factorize. Both the numerator and the denominator can be factorized. So this limit can be written as the limit of x cubed minus 2 cubed. 8 means 2 cubed. I can write it. The denominator part, x square minus 2 square, as x goes to 2. Let us recall a cube minus b cube is the same as a minus b times a square plus ab plus b square. So when you factorize the upper part, it will be x minus 2, then x square plus 2x plus 4. If you consider the x and the 2 as a and b, it will be expanded in this way. For the denominator part, recall again a square minus b square, which is a minus b times a plus b. So when you factorize the denominator, it will be x minus 2 times x plus 2. Now x minus 2 in both it can be cancelled out, and the limits remain in the topper. X square plus 2x plus 4 remain, and in the denominator just x plus 2. So as x goes to 2, now we can insert the 2 directly, because the problem was x minus 2 in both, which is bringing or which is giving us 0. Now if we substitute the 2 directly, the upper part will be 4 plus 4 plus 4, which is 12, and the denominator part 2 plus 2, which is 4. So the answer will be 3. That's B. The next question, the limit of x the power of 4 minus 1 the whole over the absolute value of x minus 1 as x goes to 1 from the left side. First of all, absolute value of x minus 1 is the same as x minus 1 or negative of x minus 1. This is going to be when x greater than 1, and this will be when x less than 1. But we are asked as x goes to 1 from the left means we need to consider the second interval here. X approaching 1 from the left means it is from x less than 1. So I will take for the denominator part negative of x minus 1. So now this limit will be the limit of x the power of 4 minus 1 over negative of x minus 1 as x goes to 1 from the left. Here again direct substitution doesn't work, it will give us 0 over 0, so we need to factorize the numerator part. So the numerator part, x the power of 4 minus 1, it can be written as x square minus 1 square. You know, 1 and 1 square are the same, but x the power of 4 can be written in this way. Again, this is the same as x square minus 1 and x plus 1. I mean x square plus 1, like a square minus b square will be a minus b and a plus b4. Again, the one which is found in the first bracket still can be expanded and written as x minus 1 times x plus 1, and the next bracket as it is x square plus 1. So the limit will be, this limit will be the limit of the upper part, complete factorization, x minus 1, x plus 1, and x square plus 1. The lower part already negative of x minus 1 we said, as x goes to 1 from the left. So we can cancel this x minus 1 and x minus 1. This was the problem in case of direct substitution. This was the one which is bringing or giving us 0. Now we can insert the 1 directly. Here it's going to be 2, and when you insert here it will be also 2. But there is negative in the denominator, don't forget. 2 times 2 will be, so the answer will be negative 4. So which is D. Let us proceed to the next question. Again, the next question, it is limit at infinity. It is sequence limit at infinity. So what to do? The same like that of the first question, the limit of 1 minus n minus 3n square the whole over 6n square plus 1 as n goes to infinity. So in case of limit at infinity, what to do? We'll divide by the highest degree of the variable. This time the highest degree is n square in the numerator and in the denominator. So we'll divide each of the term by n square. It's going to be the limit 1 over n square minus 1 over n. You know, n over n square will be 1 over n minus 3. The whole over the down part 6 remain plus 1 over n. Then here as n goes to infinity, like that of the previous one, constant over variable. As the variable goes infinity, everything will be 0. And in the numerator negative 3 remain, in the denominator 6. When you simplify, negative 1 over 2. So the answer will be B. Next question. The limit of square root of x minus 1 the whole over x square minus 1 as x goes to 1. This time again, substituting 1 directly will give us 0 over 0, which is undefined. But we can multiply the numerator and the denominator by the conjugate of the numerator. We can rationalize square root of x minus 1 over square root of x minus 1, just to avoid the square root of x minus 1 and write it as a linear part, and then we can factorize the denominator part. So when you multiply the upper part, it will give us just x minus 1, because root x square will be x and 1 square will be 1. In the down part, as I said before, we can factorize this one. It will be x minus 1 and x plus 1 multiply with, here it is another multiplier, root x plus 1. By the way, here we have to multiply by the conjugate, not by directly. Since here the numerator part is root x minus 1, we need to multiply by the conjugate of it, that is plus 1. So when you multiply, it will be x minus 1 the upper, the lower will be in this way. Then now we can cancel x minus 1. This was the problem. So the limit of what remain, up just 1, down it will be x plus 1 and radical x plus 1 as x goes to 1. Now we can insert 1 directly, so it will be 1 over, this will be 2, and this also 2. 2 times 2 will be 4. So the answer is 1 over 4, that is C. The next question, the limit of 1 minus x the whole over 1 minus 1 over x square as x goes to 1. If we directly substitute the 1, again it will give us 0 over 0. So first of all, let us complete this part, the one which is found in the denominator. 1 minus 1 over x square by crisscross, 1 times x square will be x square minus 1 the whole over x square remain. So the whole thing, it can be written 1 minus x times, we can flip this one, x square over x square minus 1. We can flip this part after completing it. Since it is division, we can flip and multiply. So what remain in the up, x square times 1 minus x remain. Down, we can factorize the denominator function, this one, and it will be written as x minus 1 times x plus 1. But here, when you try to see, the two are almost the same terms, but we have to extract negative from the upper part, and then it will be negative x square into x minus 1, and the lower part as it is, x minus 1 times x plus 1. We can take negative outside here, and then we can exchange the place, x minus 1. Therefore, now the problem x minus 1 is cancelled out, and the limit of what remain, x square over x plus 1 remain as x goes to 1. Now we can substitute 1 directly, so the answer will be 1 over 2, but there is negative here, we don't have to forget it. So the answer will be negative 1 over 2, which is C. The negative comes from here. When you exchange the place, the negative is extracted, it's here. Next one, the sequence, what you see here in the brace, it converges to its S. That means in another way, we are going to find the limit of this sequence, that is n minus 1 times 2n plus 1, the whole over 1 minus n square. We'll find the limit of this sequence as n goes to infinity. So as n goes to infinity, what will be the outcome? First of all, the upper part can be multiplied. When you multiply, it will be 2n square minus n plus 1 remain, minus 1 remain. The lower part as it is, 1 minus n square. Now since it is limit at infinity, as we were doing before, we can divide by the largest degree, that is by n square each of the term. So the limit will be 2 minus 1 over n minus 1 over n square, down 1 over n square minus 1 as n goes to infinity. Now everything will be 0 here, 1 over n and 1 over n square, again here 1 over n square, everything will be 0 as n goes to infinity. So what remain at the top 2 and the denominator negative 1, so it will be negative 2. The answer will be just B. Next question. It says, which of the following sequence is convergent? Which which of the following sequence is convergent sequence? So what to do? Let us try to see in another way. What does this mean? As n goes to infinity, which sequence will give you some constant number, like the limit of any sequence an as n goes to infinity. If it gives us some constant number l, we can say it is a convergent sequence. Let us start from b. b, it says the limit of negative 1 to the power of n as n goes to infinity. This has two possible outcome, that is plus or minus 1. That infinity, it might be, we can consider it as even infinity and odd infinity. Negative 1 to the power of even number, it will be 1, and negative 1 to the power of odd number will be 1. I mean negative 1. So it has two possible outcomes, so we cannot say it is convergent b, forget it. And what about c? When you go to c, the limit of 109 minus 1 over 100 times n as n goes to infinity. As n goes to infinity, this will get larger, because n, when it's a large number times whatever here, it will be larger than some constant minus a large number. Obviously it will be of a negative of large number. So again, see, it's not a convergent sequence, so it will be divergent. What about d? When you go to d, it says the limit of sine of 1 over n, again as n goes to infinity. As n goes to infinity, the one which is found in the bracket here, okay, 1 over large number will be 0, so it will be sine 0. Sine 0 means 0, so obviously this is convergent. Yes. What about choice A? When you see the choice A, the sequence is not given like that of the other as a formula or in terms of n, but see the pattern. It was 1, then 1 over 2, then 1 again, 1 over 3, then 1 over 4. Okay, for every odd terms, like first term, third term, fifth term, the outcome is 1. For every even number, it's decreasing. It was 1 over 2. The denominator part is increasing and getting larger and larger. Finally, for even terms, the outcome will be 0. For odd terms, it will be 1. So it's not unique, the last outcome. As n goes to infinity, the last outcome is not unique. It's not constant. It's, of course, it's a constant number like that of b, but the number is not like unique. There are two possible outcomes. As n goes to infinity, it will be either 1 or 0. So we cannot say it's convergent. So obviously, according to the definition of convergent sequence, the answer should be D. Okay, the next question, which one of the following is equal to the limit of the sequence, what you see, as n goes to 9? The limit of x minus 9 over 3 minus radical x as x goes to 9. If we substitute directly, the upper will be 0, the lower also, radical 9 will be 3, so it will be 0. 0 over 0 doesn't work. So we have to rationalize. We need to multiply the numerator and the denominator by the conjugate of the denominator here. So let's do it. Multiply by 3 plus radical x, the whole over 3 plus root x, which will be the upper part, x minus 9 as it is, times 3 plus root x, nothing will happen. But the lower part, when you multiply, like a minus b and a plus b, it will be a square minus b square, so 3 square will be 9 minus x. Now when you try to see numerator and denominator, x minus 9 and 9 minus 6, we can change, or we can extract negative and exchange the place of either of the two. Let's do for the denominator part. This will be x minus 9, the upper as it is, times 3 plus radical x, the whole over the lower part we can write it negative of x minus 9. Just always as a rule, a minus b is the same as negative of b minus a. By taking out negative, we can exchange the place of. Okay, so here, so what to do now? We can cancel x minus 9. Then what remain? The limit of, don't forget there is negative here, negative of 3 plus radical x rate. As x goes to 9, then when you substitute 9 it will be 3, 3 plus 3 will be 6. So the answer will be negative 6. So that is C. Next question. The limit of x e the power of x minus absolute value of x, the whole over x, as x goes to 0 from the left. Okay, here there is absolute value of x. We need to remove the absolute value. So absolute value of x is equal to, it is x or negative x. It will be x when x greater than 0. It will be negative x when x less than 0. But it says as x approaching 0 from the left. From the left means for x less than 0 interval, so that negative x will be taken. So the limit will be the limit of x e the power of x minus negative x will be, negative of negative will be plus x, the whole over x, as x goes to 0 from the left. Directly inserting 0 here doesn't work because the denominator is x. When you insert 0 in the denominator, it will be 0, that's undefined. So what to do? We can take out x here common. The limit will be, when you take out x, what remain? E the power of x plus 1 remain, the whole over x, as x goes to 0. Now we can cancel x with x, and then we can substitute 9. Directly the 0 can be inserted now. When you insert, it will be e the power of 0 plus 1. E the power of 0 means it's 1, so 1 plus 1 will be 2. So the answer is B. The next question, it says in which interval the sequence is negative 1 the power of n the whole over 3n. So in which interval this sequence is bounded? So first of all, let us mention some of the terms. If you insert 1, the outcome will be negative 1 over 3. If you insert 2, it will be 1 over 6. If you insert 3, negative 1 over 9. Then if you insert 4, 1 over 12, it continues. Finally, as n goes to infinity, the lower part will be large number. It will be negative 1, plus or minus 1. The upper part, as n goes to infinity, it will be either plus or minus 1. The whole over infinity. This means 1 over infinity or negative 1 over infinity. In either case, it will be 0. Now let us try to observe. From here, there will be other numbers, of course. Which one will be possibly the larger one? The larger one is possibly 1 over 6. This is the larger one from the sequence, and the smaller one will be the negative, but here it is. This is the least one, and this one is the largest one is. So this is the whole possible outcome. The 0 is found in between them, and the other numbers also in between them. This is the possible larger number of the sequence, the possible larger outcome. And the possibly the smallest number is negative 1. So the given sequence is bounded between negative 1 over 3 and 1 over 6. The answer should be B. Okay, the next sequence again. It says, which of the following is a convergent sequence? Let us see one by one. A, the limit of 5 over 3. The power of n as n goes to infinity. This will be infinity because the numerator is larger than the denominator. In case of a over b the power of n, okay, the limit of as n goes to infinity, if a is less than b, if the numerator is smaller than the denominator, then the sequence, the limit will be 0. But if the numerator is larger, it gets larger and larger, and finally it will be infinity. So it's not convergent, it will be divergent. And when you go to B, again the limit of n square over n plus 1, as n goes to infinity, the degree of the numerator is larger than the degree of the denominator. So as n goes to infinity, it will be again infinity, divergent. When you go to C, the limit of 2n over n plus 1. Here the degree are the same. So if you divide each of them by n, possibly the limit will be 2. This is convergent. If you go to D, as n goes to infinity, the D part, the limit of -1 the power of n over 3, as n goes to infinity, possibly it will be plus or minus 1 over 3. Okay, that n, as n goes to infinity, when we are talking, that n, it might be even or odd infinity, we can consider. So in case of odd, it will be negative. In case of even, it will be positive. So the 3 remain as it is. So it's not unique. As n goes to infinity, the last outcome is not unique, so it's not convergent. So the answer obviously will be C. Next question. The limit of x square minus a square, the whole over x to the power of 4 minus a to the power of 4, as x goes to a. For a different from 0, it says. So again here, we need to factorize. The upper part, the factorization form is x minus a and x plus a. But the lower part, x to the power of 4 minus a to the power of 4, we can write it x square minus a square, again x square plus a square. We can write it. You know, x to the power of 4 means x square square. Again, a to the power of 4 means a square square. So again, we can expand this. Still, it will be x minus a and x plus a times second will come. So the lower part will be x minus a, x plus a, and x square plus a square. We have this. Now we can cancel x minus a with x minus a. This was the problem. And not only that, x plus a can be cancelled again by x plus a. Finally, we can directly substitute now the a. Then what remain? It will be 1 over a square plus a square. It will be 1 over 2a square. Actually, we can do the upper part, x square minus a square, keep it as it is. But the lower part, we can write it x square minus a square times x square plus a square. We can cancel this one directly here, and then we can get this result, so the answer will be B. Next question, again, which one is convergent? Let us see one by one. The a, 1 plus 2 to the power of n over 3 to the power of n. This is the same as 1 over 3 to the power of n plus 2 to the power of n over 3 to the power of n. We can give this denominator for each of them. This sequence, as n goes to infinity, it will be 0. Again, this one, it can be written 2 over 3 to hold the power of n. As n goes to infinity, this also will be 0 because the numerator is smaller than the denominator. So 0 plus 0 will be 0. It is a convergent sequence. So the answer is obviously A. Let us check the other. If you go to B, it is 1 over n plus sine of n. As n goes to infinity, 1 over n will be 0, but sine n, it will be an oscillating function. We cannot say it is 0 or 1. We don't know. Maximum 1, minimum -1, but it oscillates. So it has no unit outcome. Leave it. If you go to C, 1 minus 3 to the power of n over 2 to the power of n, it can be written 1 over 2 to the power of n minus 3 over 3 to the power of n over 2 to the power of n. Obviously this will be 0, but this will not be 0. The reason the numerator is larger than the denominator, we can write this one as 3 over 2 the whole to the power of n. So numerator is larger than denominator means this will go to infinity. So 0 minus infinity will be negative infinity, so it will be divergent. Okay, let us see D. Again the D, what does it say? -1 the power of n over 2. So as n goes to infinity, the limit of this sequence as n goes to infinity, the upper part will be plus or minus 1, the lower as it is. So still it is not unique. There are two possible outcomes as n goes to infinity. So the answer cannot be D. It has to be A. Next question, what are the largest, the greatest lower bound and the least upper bound of the sequence given? -1 the power of n, 1 plus 1 over n. Let us try to mention some of the term, and then we will see the last outcome. If you insert 1, it will be negative 2. You know, 1 over 1 will be 1, and 1 plus 1 will be 1. And this one, it will decide the sign. When you insert odd number, it will be negative. For even numbers, it will be positive. And what the next step? If you insert 2, it will be 1 over 2 plus 1 will be 3 over 2, but it's positive. If you insert 3 plus 1 will be 4 over 3, but it's negative. If you insert 4 plus 1 will be 5 over 4, it's positive. It continues, and as n goes to infinity, what will happen? This part will be 0 and 1 remain, and finally the final outcome will be plus or minus 1. It will be decided only by the outer. As n goes to infinity, the outer will be plus or minus 1. So from here, which one is the larger one? The least upper bound will be like the larger one from all, that is 3 over 2, and the greatest lower bound will be the smaller one from all, that is negative 2. We are asked what is the greatest lower bound, that's negative 2, and the least upper bound 3 over 2. So the answer will be C. Next question. There are two functions here given, f of x and g of x, and then what is the limit of the sum of the two functions as x goes to negative 2. We can divide, you know, the limit of f plus g as x goes to some number. We can write it the limit of f plus the limit of g as x goes to that number. So using this property, let us write it. It will be the limit of f of x as x goes to negative 2 plus the limit of g of x as x goes to negative 2. When you go to f of x contain absolute value of x. So absolute value of x means it is either x or negative x. It will be x when x greater than 0. It will be negative x when x less than 0. But we are approaching at negative 2. As x approaches to negative 2 means it is in the second interval, so we'll take negative x. So f of x will be negative x over x, which is negative 1. So the limit of this part only will be the limit of negative 1 as x goes to negative 2. You know, for constant function, the limit as x goes to anywhere, it will be the constant itself. So possibly the answer will be negative 1 for the first one. The second part, for g, the limit will be, what's g of x? X plus 2 the whole over x cubed minus 4x. Here the denominator part can be factorized. This one, we can extract the x as a common first, then x squared minus 4 remain. Still x squared minus 4 can be factorized as x minus 2 and x plus 2, and there is x outside still. Then here x minus 2 will be cancelled with x minus 2 here. Then what remain? You know, don't forget plus the limit of upper 1 left over the lower part x into x plus 2 left. So as x goes to negative 2, we can insert negative 2. So what remain? Negative 2 plus 2 will be 0. Actually here I was supposed to cancel out something. Wait a minute, let's correct it. Okay, so what should be cancelled out? Let us highlight it with another color. X plus 2 is here, again x plus 2 also here. We were supposed to cancel x plus 2, not x plus 1. So what remain? The limit of upper 1, the lower x into x minus 2 remain as x goes to negative 2. As x goes to negative. When you insert negative 2 here, it will be negative 4, and negative 4 times here there is x, which is negative 2. It will be 8. So 1 over 8 remain. When you add negative 8 plus 1 will be negative 7 over 8 will be the final answer, that is D. So it's better to do them separately, f alone and g alone, and try to observe each of the case. Last question for today. The limit of 3 the power of n plus 2 the power of n over 6 the power of n. As n goes to infinity, again this one is limit at infinity. We can write this, the upper part, as 3 the power of n over 6 the power of n plus 2 the power of n over 6 the power of n4. And then here this can be written as 3 over 6 the power of n plus the second part 2 over 6 the power of n. Each of them, the limit as n goes to infinity will be 0, because numerator is smaller than denominator. This will be 0. Here also the same thing, 0. So 0 plus 0 will be 0. The answer will be B. So these are some of selected problem for today. Thank you for watching. Don't forget to share to your friends, subscribe, like, and comment.